Welcome, ladies and gentlemen, one and all. So we are back with another episode
of Eigenbros. Yes.
Yes, indeed.
This week we have a very interesting episode. We're going to call it This Week in Science.
Ooh. You need like an effect on that.
I do. I'm gonna put reverb on it for sure. But but I did want to talk about some interesting headlines that I came across that kind of have to do with topics that we've summarized before on our show.
Sweet. But let's first, of course, shout out the stuff of make sure you guys like, share, comment, subscribe. We've been not doing that lately because we got too many guests on.
Oh, true.
But yeah, guys, make sure like, share, comment, subscribe if you haven't already. Shout out to the patrons. We appreciate you guys so much. And if you, too, are looking to become a Patreon member, make sure to check out patreon.com/Eigenbros. And and check out the websites, eigenbros.com, Eigenbros on Instagram, Eigenbros Twitter, Eigenbros2 on TikTok. And let's get into it.
Yeah. So the first topic I wanted to talk about was Oumuamua.
Yeah. So this is Avi Loeb's
one of his
meteor.
Yeah, one of the many interpretations that was kind of thrown out there. This one in particular was salacious because he claimed it was something. This interstellar object might have how would you say, alien origins?
Yeah, he was claiming
intelligent life, I guess. Not alien is like kind of the loose word.
Yeah, because it is an interstellar object, right?
Is.
It literally came outside of the solar system,
and it is also technically extraterrestrial.
Yeah,
and it all technically also is alien.
Right, but he literally is claiming that it was like potentially.
Yeah,
he didn't claim it was. He said it could be.
Right.
An alien aircraft, right? Yeah. Something like, for example, maybe an alien light sail, which he still happened to invent. Coincidentally enough, but we've already talked about.
He's
Avi
like, I'm
Loeb.
as smart as an alien.
Yeah.
So for the record, Oumuamua, for those of you that don't know, in 2017 October, astronomers discovered the first known interstellar object to visit our solar system, and in University of Hawaii's Haleakala. Can you say that? Haleakala Observatory?
Oh, I think that's right. Haleakala.
Bro, I'm so bad at pronunciation. The object defied easy description, simultaneously displaying characteristics of both a comet and an asteroid. So they named it Oumuamua, which roughly translates to scout in Hawaiian. And it traveled. It kind of like escaped characterization because it was a little bit too far for our satellites to. Not our satellites,
our images to
our observatories, our telescopes, to really catch it. And they need to spend a lot of time to collect images, and because with all these image collection stuff with astronomy viewing, I believe they take an average, right? They take like multiple images, they collect light. And
sounds possible, but I would imagine they probably would have something that could take more real-time data, but I don't know.
Yeah,
I don't know enough about astronomy. If you guys are astronomers in the comments,
I've done it on an amateur level, but
which is very different from
it's very
real
different.
Astronomy.
I would hope so, because the way that I used to do it was you just track an object, and then you pretty much collect data on like see if it changes, like the light changes. And I'm sure you have instrumentation that detects the light and how it changes over time.
Right. Yeah, I used to do amateur astronomy too. When I was a kid, my dad got me a telescope for Christmas.
Yeah.
But then I just wanted to peek at the neighbor's house. He took it away.
He was like,
Yeah. He's like, this has to go.
This perversion has to leave this boy.
Right.
He's too curious for his own.
So needless to say, I wasn't into astronomy for long.
You're like, ooh, stars, cool. Anyway, let's see what Tommy is doing.
That was pretty much literally what it was. Funnily enough, my neighbor across the street was also named Tommy.
Oh, nailed it. But yeah. So anyway, so the fun idea of the hypothesis was that it was alien-like or sort of built by some kind of intelligence because it had this weird, peculiar shape, right?
That was one reason, because it was
Yeah.
like a flat disc, they were saying, right?
Yeah.
They were getting, I think, luminosity readings from it. And they could see that when it would turn towards the light, it would have a bright luminosity, and then it would flip and then go real dark. So it had these real big oscillatory peaks.
Yeah.
We discussed it in the Abi Loeb
We
episode.
did. And just a quick overview. It had this like, it was cigar-like and had this like weird spin pattern. It looked cigar-like depending on the
Yeah.
the
Because if you look at a disc from the side, it looks like it could be a cigar.
Right.
I think the shape is still kind of undetermined. I'm not sure. But they think it's a disc shape because of all the evidence that they gathered.
So it took 3 years, just about. Recently, some scientists at the Arizona State University put out a paper. Two Arizona State University astrophysicists, Stephen Desch and Alan Jackson, at the School of Earth and Space Exploration, set out to explain these weird features. And what they found was that this weird sort of how would you say? They have this artist rendition. Maybe we can put it on the podcast, but it looks like how would you describe
Flying hamburger, literally.
it looks like a hamburger patty. They got this rendition of it.
hungry.
Yeah, and it's got this weird it's flat and it looks very, very tasty.
Yeah. They got good taste out in the interstellar world.
It's a pancake shape with more flattened than any other known solar system object that we've seen so far. And they observed that it acquired a slight acceleration as it pushed away from the sun. They call this the rocket effect. So that's like basically the sunlight vaporizes the ice on this like interstellar object, and it pushes. It gives it a little boost.
Yeah, which is a normal property of comets.
Yeah. So they were wondering what the heck is going on, and so they ran a couple models, and this is how science happens. You know, they said we realized that a chunk of ice would be much more reflective than people were assuming, which meant the object could be smaller. So the size of it is probably exaggerated because they're saying, well, a chunk of ice, you know, the intensity of the light, it's probably much smaller than it is.
I see.
And they ran some models and said the same rocket effect would then give Oumuamua a bigger push, bigger than comets usually experience, if this is just solid nitrogen. So if this object is completely made of solid nitrogen, by the way, solid nitrogen is very, because I mean, space is cold.
Yeah, sure.
You can't have solid nitrogen in space, right?
Yes, I think it's 5 Kelvin you need to be.
Yeah.
Which I guess will translate to what? Negative 260 something degrees Celsius.
Yeah. Well, space has like it's
Am
like
I
almost
fucking up?
it's like about 2 Kelvin, right? Coldness. In
Yeah,
space.
I don't know.
Yeah, I'm gonna say yes.
But if that's true, then yeah, that's well below, what
Yeah.
you need to cool nitrogen.
Yeah, and they said since solid nitrogen ice can be seen on the surface of Pluto, it's possible that a comet-like object could be made of the same material. So they said we knew we had hit on the right idea when we completed the calculation for what would make the motion of Oumuamua match observations. And sure enough, they said that they can pretty much see multiple bodies of I guess planets, covered in nitrogen ice like Pluto and Triton. So then they calculated a rate at which chunks of solid nitrogen ice would have been knocked off surfaces of Pluto in similar bodies, and the probability that chunks of solid ice from other solar systems would reach ours. And yeah, sure enough, it's likely. And this pretty much matched everything that they've seen, like it being a solid nitrogen ice body. So with good evidence, it's more than likely not alien technology.
Go figure.
Yeah. Yeah. So yes, they pretty much started saying like Avi Loeb is a crank. No, I'm just kidding. I'm kidding, Avi. Like don't take that. Don't take it to heart. They were just saying we have more. We have to not give up on the scientific method and go to like crazy wild assumptions, I guess.
And to be fair, I don't even think he really. He never claimed there was aliens, right? He never said it was most likely aliens even. He just said it's possible it could be.
Yeah.
But still, for me, that little bit of evidence is still quite a jump to even.
Yeah.
I mean, if you really just did it in passing saying it could be maybe.
You shouldn't have written it in the paper.
Yeah, and the paper is a little bit much.
Yeah. Don't write that line.
I mean, maybe it just depends.
You
The
think
thing is, his whole career is just too centered around that.
He loves, by the way, the man loves aliens.
He does. And all his papers, or a significant chunk of his papers, are alien-centric. That's the problem. Like, if he wasn't so bought into selling his stuff with aliens attached, then I would be more fine with it. But he's literally, it seems like his game is more so fame over like actual, you know, good research. I mean, he's known and he's at a respected institution, so by no means is he a slouch. But it's just like, bro, we know your book just came out, so I get why you're saying aliens.
Yeah, he's a professor at the Harvard Business School of Cool Science Ideas.
Yeah, right.
Yeah. No, yeah. So hopefully you can all go to. I know you were all clamoring at this and go to. Now you can sleep at night knowing that this wasn't a weird alien space probe.
Yeah, no abduction averted. Don't worry.
You won't be probed by an alien spaceship anytime soon. Okay.
Your anus is safe.
Yes. Yeah. Why we mentioned this the other day, didn't we? Like, why did aliens have this kind of reputation?
Right.
Why are they perverted? Yeah. No, but this speaks more to the psychological trauma of like how humans perceive traumatic events. Yeah. By the way, if you're curious about this, we're not going to go into this, but there's an interpretation, a reason why I guess people correlate these two events. Like what it was.
Did we talk about this?
No, we didn't.
Okay.
We talked about this off air, but
yeah.
It was there's a correlation
between trauma and abductions.
Yeah. And how people that experience
alien abductions
also have experienced weird traumatic events.
Yeah.
And they mask their trauma with with alien this.
It's kind of like one of these repressed memory sorts of deals. Yeah.
Right.
Yeah.
So, but not to say there's some people that have seen weird shit.
Yeah, sure.
For sure.
We're not discounting all alien stuff. You know, of course, Eigenbros podcast is basically an aliens podcast as well. So
we're very much skeptics. We want to believe.
Yeah.
But what is that saying? Something
extraordinary claims require extraordinary evidence.
Thank you. Yes.
Yeah. So, we're scientists first and foremost, so we can't believe shit unless it's really fucking solid.
Yeah, I take everything I hear with a little grain of salt.
Yeah.
The tiniest little grain. Mm-hmm. Right next to the tiny violin that I play sometimes.
I got to hear that.
Yeah. It's awful. So the other article I kind of like happened upon was published in Nature.
Which are you reading on Nature, or do you go for a particular website?
No, I just Google's like, hey, check this out.
Okay, so you just go with the Google News feed, basically.
Yeah.
Okay, yeah.
Yeah, my morning, cup of Joe kind of thing.
Yeah, because I still haven't really found a great resource. Like the best resource I use for science is Quanta magazine.
Yeah.
I love Quanta, but they have only since they're so high quality, they only come out seldomly with a new article. It'll be once every few weeks. But if you guys find any good other science article places, by all means, shout it out.
Yeah.
Because I'm still looking for some other ones.
Yeah, I like to inform. I hope our podcast is sometimes informative.
That's kind of the point.
Yeah.
So it better be.
Yeah. This article came out in Nature. It said birds have a mysterious quantum sense.
God.
Terrence is rolling his eyes.
I'm already cringing a little bit at
and
the
they use
title.
Quantum sense in quotations. For the first time, scientists saw it in action.
Mm-hmm.
Okay. So
I'm waiting for this quantum sense that birds have.
Yeah.
Whatever that even means, but okay.
So birds have this ability, this well-known ability to, they just have this genetic mutation that allows them to see Earth's magnetic fields. They can also see UV in the visible range.
And they have confirmed this.
Birds, yeah.
They confirm that birds can see in an electromagnetic field.
I mean, they say, yeah, something about their visual system allows them to see our planet's magnetic field.
Huh.
Yeah.
Damn, that's cool.
But we know that they can also see in UV. Like, they see in a spectrum that we can't. But that's
Yeah, other things do that. A lot of things do that. And that makes more sense to me.
It does. But
seeing an E field or seeing a magnetic field is a little bit more foreign concept to me.
Yeah, isn't that strange?
Yeah.
Well, I guess it's kind of like seeing the aurora.
Yeah, but that's translating a magnetic field into light.
Oh, I see what you're saying.
You see what I mean?
But that's maybe what they see. Well, except without the wild colors, probably.
Yeah, I'm just like, how would it do that though? Like, by what means or what?
They must
mechanism?
be tripping out all the time. Imagine seeing all these weird like.
But the nice thing is the Earth's magnetic field is so weak.
True.
Maybe it's not so. Maybe it's not tripping them out so much.
Yeah. Yeah, man. What the hell?
Yeah, it's weird. Seeing a magnetic field, I can't even really. But I guess the magnetic field is literally the part of the electromagnetic field, right?
Yes.
Magnetism is weird though, because I still barely even understand how magnetic fields rise.
Well, because they're not even that natural to our experience.
Yeah, because we know that magnets basically come from, like, if you imagine an electron, right?
Yeah.
It's the spin of an electron has an intrinsic magnetic moment, just like they have intrinsic charge.
Yeah.
But then sometimes it's hard to see how those two connect, because it's the electromagnetic force, right? So electricity and magnetism are supposed to be one and the same force.
Yeah.
But then it's like, how is spin separate from charge? And then, see, these are questions I still like. I feel like I should know, but I don't know.
These are fundamental questions of physics that I think. It's very interesting. There's like without getting too bogged down in the weeds, there's some commutativity, I guess, to them. Like these, like magnetism and electricity, like you're saying, they're two sides of the same coin. But you're saying, how can they be? I mean, I've always interpreted that as they all, magnetism and electricity come from the electron. You know what I mean?
Yeah.
So I think that's what people mean. I don't know if it's like.
Yeah, but it still is not clear, because it's like, no, it's like
moving
they're
charges
tied somehow.
They are. I mean,
because they both have the same force mediating particle.
Yeah.
Right? They're both using phonons.
Yeah.
So
I mean, moving charges generate magnetic fields. So yeah.
Yeah, that's another weird one.
Yeah.
That I think we probably talked about before with Purcell. Purcell has that analogy. He shows that the magnetic field actually rises due to relativity.
Yeah.
But then
Purcell
I think
by the way, Purcell is an author. He's a book. Very good book. Yeah.
He shows how moving electric fields can translate into a rising of a magnetic field. But I still don't really believe that.
You can choose a specific, how would you say?
Reference frame.
Reference frame, yeah.
But I don't like it fully, because it's like it shouldn't require relativity, right? Because you can have magnetic fields generated from slow-moving charges too, right? So relativity shouldn't have to matter.
But sometimes it be that way.
The universe be like it is, as black science man says.
I'm sorry. This is anyway. Yeah, we're gonna bring you an episode. Me and Terrence were contemplating giving y'all an episode on E&M essentially.
Yeah, but we need to study
crash
more.
course. Yeah. But it would be answering these questions more fortuitously, getting down into the nitty gritty. I mean, there's still questions like this that are being answered today. We fundamentally, like, you know, it's phenomena that probably requires more. I don't know, because I mean, you were telling me the other day about the gravito. What is it?
Gravitomagnetism.
Yeah.
Yeah. So there was some paper that got released by this guy who was trying to find a way to explain dark matter.
Mm-hmm.
And he found out that you can actually explain it using the gravitomagnetic force.
Mm-hmm.
Don't ask me too many details because I didn't study it enough to know what it was saying.
This sounds like particle physics with some, I don't know, E&M stuff.
E&M is definitely involved.
Yeah.
Maybe you're right. I don't really know for sure. All I saw was I saw it from a first post from Will Kenny online on Twitter, and then I noticed that Garrett Lacey did a proof on how it's, or not a proof. I guess he did a back of the envelope calculation on how it breaks down, because there was something he checked against that it had like 6 orders of magnitude too high or too little or something, too small, I think maybe.
Yeah.
But there was some gravitomagnetic explanation for why you would see certain gravity effects on celestial scales, right? Because that's the whole reason why dark matter was invented, was because people were seeing that the galaxy would not move with the right, I think with the right angular speed, I want to say.
Right.
Or something along these lines. I think it had something to do with angular motion.
Yeah.
With the matter it currently had. It had to have like much more matter.
There's
and that was
missing
the
mass,
dark
right?
the dark matter, right?
Yeah.
So it showed how that everything in the celestial scale needed this. So then they figured out that, dark matter is actually a significant part of this universe. And then even Sean Carroll did a post on it as well, showing, but his was just saying that dark matter is a real particle, and he was showing that dark matter is a particle because of some other effects. He had some nice arguments of why it existed. He showed some other means of just being a number to fill in those gravitational anomalies. He also showed that there were other things, I think like maybe lensing effects and things as well, or something along those lines. I don't remember all the details, so this is really going to be a poor man's explanation.
It's a loose idea, yeah.
Yeah. But it was interesting. It seemed like dark matter was on people's minds this week.
Yeah. Well, I mentioned that because it's like, I mean, you're talking about combining gravitomagnetism, like what the
yeah,
just
I
like,
don't know.
okay. Yeah. So anyway, we say all that just to say it's a very deep topic, and we still have a lot of unanswered questions, I guess, within the field. So going back to this, wait, were you going to say?
No.
Going back to this paper here. So something allows birds to see our planet's magnetic field, and certain physicists or
maybe it's not
scientists,
see, maybe it's just feel. There's journalists writing.
Right.
They don't know a good word. Maybe detect would be better.
Yeah, they can detect our planet's magnetic field.
See implies you're changing that with your visual cortex into visual information, right?
Right.
Which is not. I don't think that's necessarily the case.
They can definitely. Well, they can sense
the
direction of the planet's poles.
Yes, sense is a better word.
They have
see maybe is a little bit. I'm skeptical.
I mean, birds eat rocks. I don't know if you've seen them peck at stuff, but they
eat rocks.
They eat rocks because they're trying to get the ferrite. You know what I mean? They apparently collect the ferrite, and this ferrite actually allows them. They can grind it, and it allows them to store it. I guess in a special.
Damn, is this for real?
Yeah.
Damn.
Yeah, I mean, millions of years of evolution, bro. They give you. Oh, you want to see something cool?
Right.
We'll give you this ability. You level up and get.
The village idiot bird just ate ferrite just because, or he just ate rocks because he liked the taste, and then eventually evolution justifies the idiot actions.
It's like, I feel kind of weird. The bird's like flying. It's like, I can now feel where I'm at. But they were saying for the first time ever, scientists from the University of Tokyo have observed a key reaction hypothesized to be behind birds' many other creatures' talents for sensing the direction of the planet's poles. This is evidence of quantum physics affecting a biochemical reaction, something that scientists have long hypothesized. Now, using a tailor-made microscope sensitive to faint flashes of light, The team watched a culture of human cells containing a special light-sensitive material respond dynamically to changes in the magnetic field.
Interesting.
So there's a fluorescence dimming as the magnetic field passes over it. And the change the researchers observed in the lab matched just what would be expected if a quirky quantum effect was responsible for the illuminating reaction. So they're saying, I mean, to me, what's still kind of interesting here is what, I guess, where the quantum reaction is involved. But I don't know. They claim that the quantum reaction occurs in the photoreceptors. They call them cryptochromes. Cool ass name.
Cryptochromes. We got some cryptochromes somewhere.
Yeah. Bloods and cryptochromes.
Ethereum and
Right. Well, yeah, I was thinking about something else.
oh, you're thinking about gangs.
Yeah. My bloods and my bloods and the cryptochromes. Cryptochromes are found, by the way, in cells of many species and are involved in regulating circadian rhythms. So in species of migratory birds, dogs, and other species, they're linked to the ability to sense magnetic fields. So we have cryptochromes as
humans do.
Yeah.
Okay.
So there's evidence that we're not conscious of it, humans can still detect Earth's magnetic field.
Interesting.
Yeah.
Which is shitty detectors. We can't even consciously understand.
Well, we already know this is a phenomenon of human beings. Like we're so much information that our conscious.
It has to block out a bunch of shit just so you can function, right?
Yeah. What is this? 100% of our. Maybe this is what there's people that say we don't use 100% of our brain.
That's just a completely misnomer, though. I think it was coming from they were saying you don't use 100% of your brain at one time.
Right.
Yeah. Like it's always lit up in sections.
Yeah. But what if you did?
Then you'd be screaming like,
I'm
what
kidding.
the fuck is going on?
You would have an epileptic seizure.
Yeah.
For sure.
Right.
All the visual information that you're getting, all the auditory information you're getting.
Right.
Just an overload.
Sensory overload.
Yeah, for sure. Yeah, these cryptochromes, what was I going to say? So basically, they're saying that the fact that, spin is involved in these cryptochromes, as Terrence was saying, spin is...
Yeah, spin is fundamental to magnetism.
Yeah. And I don't know if should we go a little bit more into that? No, you think?
In spin?
Like describe for those not in the know?
Sure, you can just imagine electron as a tiny bar magnet, literally. Mm-hmm. If you just imagine the smallest bar magnet you can, that's basically what an electron is. And if we want a magnetic material, for example, it's just a bunch of bar magnets that are misaligned. And then once they all become aligned, then you have a magnetic field, because you add up all those magnetic fields together, and then there it is. Yeah.
I mean, pretty much. They were trying to explain here what the heck is going on, but there was a professor named Klaus Schultin in 1975. He said there's at the Max Planck Institute, by the way. Shout out.
Okay.
Yeah.
Who's at Max Planck that we know?
No one.
Oh, we just know Max Planck is
Max
legit.
Planck is amazing. In 1975, they developed a theory on how magnetic fields could influence chemical reactions, and it involved something called a radical pair.
Mm-hmm.
Radical, dude. A radical garden variety radical is an electron in the outer shell of an atom that isn't partnered with the second electron. So basically the electrons pair up in another atom to form what's called a radical pair. The two stay chemically unpaired, but they're considered to be entangled, which in quantum terms means that their spins are coupled. And this coupling effect, as Terrence and I know, like it allows you to reach more complicated states as opposed to the singular state, right? Because an electron's by itself, you can consider like the Hamiltonian to be just very simple, right? It's just the Hamiltonian, the total energy of that one electron system.
Sure.
But as you involve more and more systems with electrons, you basically entangle them, you couple them, and
Yeah. So the Hamiltonian, actually, you have to add all of them into one Hamiltonian now.
yeah.
If you know what that means, then that's fine. But
It's total energy. It just means
Doesn't
that
mean anything, really.
the more
It means
electrons you
something
add in the
physicists-
soup,
yeah,
right? It's like
But it's very subtle, though.
it kind of is, yeah.
For those of you who understand what Hamiltonians are, then this will be useful. But for those who don't worry too much about it.
Yeah, and like entanglement, I'm pretty sure you've heard all this like stuff.
yeah.
Like
They've heard about entanglement probably, but they probably don't know what Hamiltonians are if you're a layman,
yeah.
or why they're even useful.
So how would you explain entanglement? I mean, it's easy to say correlations. Like,
Yeah, I mean, it's literally just entanglement is like now one thing affects the other, basically, if you want
Yeah.
to keep it real simple.
Mm-hmm.
It's that now for you to describe how one thing acts, you have to describe how the other thing acts. Or it tells you how the other thing acts.
Yeah, and this spans like space and time, right?
Yeah.
So yeah.
Yeah. Like you can have something entangled on one side of the universe with another thing on the other side of the universe. So distance seems to not matter at all.
Mm-hmm. Which tells you something interesting about, information travels faster.
Don't say it.
Well,
You're already fucking
let me
up,
say this.
Juan.
Let me say this. Conscious observers do not. There's a cost to information. Conscious
Yeah.
observers do not. They have to pay the price of the speed limit to receive information.
Yes. So information, though,
Can't.
information requires someone who can use that information to be information, right?
Yeah,
So don't say information travels faster because it's not conveying anything.
that's true. Okay, fair enough. Because you don't know.
Yeah.
Okay, fair enough. All right.
If there's nothing to know what information is, then
Yeah, but
It's
I guess
really not
the
information.
paradox that gets into discussion here is how do you know if you're currently not entangled? And that's kind of the thing. You don't know, right?
if you're currently not,
Like if something, how do
measure
you know if
yourself,
something's
and
not?
now you're not.
Now you're untangled.
Is that what we're getting at?
Right. Yeah, there you go. So they're saying that like these cryptochromes become entangled or correlated, and so they see this relationship between the spins of two individual electrons, and how they come to play in biology.
Okay.
So basically, what happens is when these cryptochromes feel the magnetic field, it collapses the I guess the spin state of this.
Okay.
And so they're kind of correlating like, there's probably something quantum mechanical happening here. They still don't know the mechanism.
Right.
But there is evidence that I guess like consciousness can sort of affect quantum systems or whatever. But that's kind of a loosey-goosey kind of thing, isn't it, right? Wouldn't you say? Like saying...
Maybe, I don't know. I have to see it.
Wouldn't you say like somebody came up to you and said, yeah, birds,
Yeah.
bro, they collapse the wave functions by just...
I'll just be like, okay, and I would avoid that person.
But
Thinking there's some
maybe
crazy guy on the
you
street
can
talking to me.
elucidate. I was thinking maybe we could elucidate why this is like not as scintillating or like I guess as interesting as the headlines trying to make it seem. I mean, it is interesting. You know what I
Can
mean?
you explain it again?
Terrace is falling asleep over here.
Yeah.
He's like, birds, yeah, dude.
My bad.
Birds are fake, man. It's government conspiracy, man.
Can you explain it again, though?
You got to think about it.
Cryptochromes. No, just cryptochromes, bro. The magnetic field. How can the magnetic field affect a photoreceptor? I guess. You know,
But what does that have to do with quantum?
because the cryptochromes, they have this like they're sensitive to light, and it's basically like the what do they call the radical pairs. They're sensitive to this change in light or something like that, and they're affected by the magnetic field. If they're sensitive to changes in the magnetic field, and they collapse the photoreceptors, I guess. And so, yeah, it's like this weird thing. There's a correlation, but it doesn't seem that strong. I wouldn't say
I'm
that
not
that's
sure.
consciousness like affecting the what did you say? What did they say? I wouldn't say that this is a quantum sense. And then, by the way, this paper came out in like this year actually, published in Nature. A lot of these articles actually come out, or a lot of these papers come out and they get published in Nature, and it's like a lot of stuff hasn't really been. I mean, you have to pass the peer review process. Like it, yeah, you can get published, but it still has to be. It still hasn't been fully verified by the scientific community, because peer review just means that, yeah, somebody in your field will look at the paper and be like, I can believe it.
Yeah.
Right? Oh, like three
Right.
professors or whatever say, I can believe it.
Yeah.
And then once it passes, now you're really at the scrutiny of the community, right?
Right.
Yeah.
Yeah,
Because they don't really necessarily know if it's all good or not.
Yeah.
like if your methods were good or
Yeah.
Even if your conclusions are right. They're just like,
yeah.
they use their physics knowledge they know and then say, yeah, this seems like a good paper.
So at large, I guess, like, I'm trying to get a sense of, like, because you rolled your eyes when you heard quantum sense.
Yeah, just because I know that people love to throw quantum into everything. So
Yeah.
I'm like, the thing is, Nature wrote it, so I'm a little bit more inclined to. Or right, it was Nature. Or no?
Yeah, Nature, yeah.
Yeah, so I'm more inclined to listen, but quantum thing using quantum as an adjective usually gives me an eye roll, unless it's like a straight up, like reliable physics paper.
Mm-hmm.
What was the name again? Quantum what?
Quantum sense in birds,
Yeah,
essentially.
it triggers something.
Yeah, anytime. But this is why I kind of wanted to bring it up, because as listeners, if you're reading scientific news, you want to be careful with quantum being kind of thrown around, because it might not necessarily be a quantum effect. Because quantum, quantum
Quantum implies something very specific, right?
right?
Like
Like,
it needs to be-
what would you say is the cutoff of something a quantum? What would you consider a
Well,
quantum?
when I think of
something
quantum stuff, I think of things that utilize quantum effects that are specific to quantum mechanics, right?
like spin?
It's like,
Would you say?
yeah, it depends,
Okay.
maybe, but I'm talking specifically like superposition or entanglement or things along these lines. These are quantum effect. These are like quantum properties.
Yeah.
So
Yeah, I think we had this discussion with the professor. He was like, "What would you consider quantum?"
yeah.
Yeah, and I think
you need to be taking advantage of some quantum properties.
some uniquely quantum properties.
Yeah.
Yeah.
Like each regime of physics has its own axioms.
Yeah.
Like for instance, with classical mechanics, there's Newton's laws. F equals ma. It's kind of an axiom.
Yeah.
Inertia, objects in motion stay in motion. These are like axioms. In quantum mechanics, the axioms are things like, they're a little bit more esoteric because they use not stupid, but they use some math things, so it's kind of
Yeah.
like, okay, but it makes sense if you understand it. But one of those axioms could be like particles can be in superpositions. I think that's an axiom, isn't it? I don't
Yeah.
remember if it is.
Yeah. Well, Shankar is the more popular book that has quantum axioms.
Okay.
I think they're the only book that really lays it out like that.
Okay.
Yeah.
Yeah, you could look it up. I don't remember exactly what they are. I know there's something about hermitivity, but
Yes.
that's where the math
Shankar
comes in. I
has the
wanna
more
touch.
famous postulates of quantum mechanics. You can look it up. It's
Okay.
Yeah, but what was my point even? I don't know.
you were saying, like, what makes something uniquely quantum?
Right,
Yeah.
right. So they need to follow some of those quantum axioms or have those quantum properties somehow.
Mm-hmm.
It needs to be relevant for the system.
Right. Because I guess a classical mechanic ball can have spin, right? Like you're saying.
Right, but if
but
we're
in the
using
context
spin
of
as a
quantum
reserved
mechanics,
word,
yeah,
right?
yeah.
Because spin is different from like quantum spin is different from classical spin.
Yeah.
Quantum spin is actually like a specific reserved word, meaning spin of an electron or spin of a particle, which is it's different, right? And
The context is different.
Yeah. It's just using the same word though for a different meaning though. And classical spin, of course, is like actually spinning.
Angular momentum.
Yeah. Maybe something along those lines. So
It's different.
Yeah. And there have been classical interpretations of this, but the thing is, the electron also behaves. There's classical like interpretations or manifestations of how would you say electron behavior, you know? Electricity and magnetism. Well, no, that's like photons, I guess. But then there's some stuff. Electricity and magnetism in some sense is like maybe like the cumulative effect of electrons and the cumulative effect of photons, right? Wouldn't you say? Maybe that's a good
Electricity
one.
and magnetism is a cumulative effect of electrons.
Like it's like like a sort of the emergent effect. Like electrons moving through a wire
Yeah.
gives rise through to an electric field. I mean, a magnetic field, right?
Okay.
You know what I mean?
Yeah, but I don't know about your definitions though.
Because I mean, you're conducting. If electrons are moving through something, a material,
Mm-hmm.
you're they're being conducted, and
There's a current.
there's a current,
Okay.
and then that current gives rise to a magnetic field, and you basically have electricity, at least an aspect of electricity and magnetism.
Okay.
Then you have the Lorentz force, right? You know,
Mm-hmm.
there's a force that's pushing these charges.
Mm-hmm.
There's so much that happens from the cumulative properties of electrons moving as a unit or together or something. And photons, like we have coherent like phases, I guess, and I guess like maybe I'm getting too bogged down in the weeds here.
Yeah.
I'm losing Terrence because he's knocking off. Anyway, I'm saying like there's more nuance to. There's a reason why I guess quantum mechanics is kind of primarily, how would you say, focused on what makes it a defining system. Quantum mechanical is entanglement and
Superposition.
superposition.
And then maybe some other stuff that I don't remember.
Off the top right now.
I think those are really the two main important ones.
Yeah, I think so.
Yeah.
Yeah, I think so.
Yeah.
Yeah. Anyway,
Yeah. But
did you have
anyway,
another topic, or was this
I did.
just
I
the
did.
two?
I have another
Okay.
one. And this one's gonna
What's the
piss.
time
This
looking
one's gonna piss you
So I
off.
really am like falling asleep.
this one's gonna piss you off, Terrence.
Yeah, what's up?
Scientists propose a quantum theory of consciousness.
I remember you mentioning this to me already.
This is written by Brett Weiss.
Oh, that sounds familiar.
Yeah.
Weiss.
Yeah.
Okay, I know he's a guy that's like known. I think.
Mm-hmm. Yeah. So in 2019, John H. Zhang from the Center of Neuroscience Research, with at Loma Linda University, along with colleagues at Fudan University in China, published a review in the Annals of Translational Medicine, where they comprehensively described a quote-unquote prevailing contemporary theory of consciousness that evokes principles of quantum physics called this. Are you ready for this?
Yeah.
The
let's go.
orchestrated object reduction theory of consciousness. They call it ORC-OR.
Okay.
Stuart Hameroff, an anesthesiologist from the University of Arizona, and Sir Roger Penrose, the University of Oxford, developed this theory in which they use principles of quantum physics to describe how neural processes facilitate consciousness. Instead of chemical interactions between neurons giving rise to consciousness through neurotransmission, Hameroff and Penrose postulate that microtubules, or microscopic tubular structures in cells, transmit and store consciousness events in the brain. In fact, they compare microtubules in the cells of the brain to transistors in computers that amplify and transmit signals. So consciousness has, like, for the longest time been a topic relegated to philosophers, right?
Yeah, pretty
Yeah.
much. And I'd still say it is.
Really? I mean, but don't you think...
Maybe neuroscientists can touch on it a little bit.
Yeah. But
Can physicists? I don't know.
you physically, I remember you saying this, you saying physics don't belong in this realm. And I think that's not entirely, I don't
know if we're ready. I don't know if we're ready yet.
I think we can tackle it. I think maybe we can, bottom, because I hate to put philosophers on the bottom of the rung, but like,
Well,
I mean,
when has a philosopher ever solved the problem?
That's all I'm going to say.
oh my God. No.
I'm sorry if you're a philosopher, but
Consider becoming a physicist.
join the modern world.
I would say if you're a philosopher, no, I mean philosophers now mainly study the human condition. I don't know.
Okay,
if,
that's legit.
Yeah.
That's legit.
Yeah, if you're looking,
But there are philosophers that try to study physics, and it's like, bro,
do a little math.
We don't need you. I mean, you're not
Well,
useful really here.
Yeah, I mean, if you're a philosopher, I would say, and you're interested in this stuff, yeah, do a little bit of math. You know.
Yeah.
Yeah.
Or
Get a little
just
acquainted.
be a physicist or a mathematician, because you ain't gonna solve things with your mind like fucking Chris Langan with your cosmic theoretic model of the universe.
So I think more physicists need to step into this realm. It can be a top-down approach,
Okay.
just because, like, philosophers have tried coming from the bottom up. They try to answer things using, like, I don't know, loose language that's observations that aren't really categorized. They get into notions of like a soul or some weird esoteric, like, immaterial thing.
Sure.
You know what I'm saying? Because
sure.
they lack the, how would you say, the technicality or maybe the language.
Yeah, maybe they're not convinced of all the evidence that exists for things that exist nowadays.
Yeah. Yeah, and so for
Start playing
me,
with a soy sauce packet.
God damn it. No, it's too wrinkly, Terrence. Don't do that.
In the audio. Oh,
Yeah,
true.
yeah.
My bad.
The what happens is, like, to me, by the way, philosophers need to update their language, because there's a very famous thing that just happened on this TV show called WandaVision from an MCU.
Okay, I haven't watched it yet.
At the end of the, spoiler alert,
Yeah, spoiler alert.
they have this conversation about, well, I won't say who, but I'll just say there's a conversation about the ship of Theseus. Have you heard of this?
Yeah, but I don't know. I'm not familiar.
The ship of Theseus is like this.
Some Greek tale, right?
Yeah, the story of, like, there's a ship in a bottle. If you replace elements of the ship over time, is it still the original ship?
Yeah.
You know what I mean? But it looks exactly the same, but every bit of wood that has been replaced over time, does that make it still the same ship?
Right.
There's a question of identity and, like,
Yep.
what makes something what
Right.
it is.
Because even humans, we have every cell in our body replaced over a 7-year.
Every atom in
period.
our body is replaced every,
Yeah, that's what I
every
mean.
8 years. Yeah.
Yeah.
Something wild like that.
Yeah.
Which means
So we're
I'm
literally
not
not the same person that.
Yeah.
You were 8 years ago.
Yeah, legally. Legally,
The cop pulls you over. You're
Yeah.
like, "Are you on?"
Yeah.
You're like, no.
did you sign student loans 8 years ago?
Yeah.
All the
no.
student loans I signed, yeah.
So it's not perjury if you like, or it's not a lie.
That's not even me anymore. I don't know who that is.
That's a completely different person, literally.
Literally not me. But there's this concept of identity and stuff.
Uh-huh.
By the way, I'm not the first one to come to say that joke, but, like, I'm sure this is like, I'm sure that people have tried to weasel out of contracts using science. But yeah, I would say, like, philosophers need to update their language, because now physics is starting to come into the realm of, like, biology, and they're saying, like, well, like, humans are, like, kind of like, or life, complex life, or life itself is, like, kind of like these, we kind of hinted at it in one of our episodes, information constructs or something, right? They're like,
Right.
They're sort of organizations.
Yeah, that was the one we did with Gabe, right?
Yeah, Gabriel. Yeah.
That was an interesting topic.
Yeah. Yeah. Life itself is like this sort of information construct that perpetuates copies of information. Like, a copy is information. You know what I mean? It's like,
It's hard to really get into the understanding of that.
Yeah.
Because it's so deep.
yeah. It's
But
such an abstraction for, like, yeah.
Yeah, but I guess the nice, real takeaway I have to really get my brain in the mode is basically you're saying how information is this real fundamental part.
Yeah.
Like, because, we'll think of the world as fundamental particles. We're thinking of things as, like, fundamental, like, fields. But really, you can say information is kind of a fundamental part.
Yeah.
And that kind of arises when you talk about things like entanglement, like we were already.
Yeah,
like,
yeah.
Information is the fundamental piece of is the fundamental part of the universe or something.
Yeah.
And Shannon talks about this in his seminal paper. quantizing, or not quantizing, but quantifying how to transfer information and whatnot.
And there's costs associated with transactions and like all.
And there's
this other stuff.
there's even like a Shannon entropy that has to do with information.
Yeah.
It's the same form as the entropy equation, but it's now for information, right?
Yeah.
So it's pretty crazy. Like, it's actually this real fundamental thing.
Yeah.
And people have been analyzing the world now in terms of information, actually.
Yeah.
Which is more abstract than what we're used to dealing with.
And biology seems to be also one of these, like, biology is probably the most, I would say, egregious out of all information, like, structures, because it's, like, so blatant, like, that you're trying to copy information, like you're trying to keep something
with like DNA or RNA. Yeah. Right.
And you're trying to like you're trying to replicate information, and you're also trying to keep information the same. You know what I mean? Like you're fighting, you're almost fighting entropy just to keep something.
To keep the state retained or something.
Yeah, it's very interesting. Like, and I don't know. Consciousness is one of these weird ones where it's easier for me to conceptualize life, like material life, as like, oh yeah, it's a thing that tries to self-replicate, and its sole purpose is to I guess, physics allows it to exist because it increases its local.
Decreases
local entropy.
Yeah.
But maximizing the global entropy. Right?
Yeah. Entropy will always go up, right?
Yeah. But consciousness is one of these weird ones where I'm just like, yeah, maybe you are organizing information. It's one of these things like the consciousness serves to organize information. You know what I mean? Like it does this weird process.
Consciousness serves to organize information.
Like you're interpreting. You're not. Imagine a blank slate. You're just a camera. You're just a camcorder.
Yeah, I guess so. So. Or maybe not even organized, but even just manipulates information.
Okay.
Because organized is a little bit stronger statement, right? Because it implies that there's some kind of
sorting.
Yeah. Or some kind of like method to the madness.
You think there's no method?
I mean, maybe there is. Maybe it is organizing information. I'm trying to think of it as the deepest level. I just didn't want to make a strong statement because I haven't thought about this.
Right. Okay.
Like these super deep concepts, you almost don't want to talk about sometimes, until you've thought about it for like a month.
Right.
But maybe you're right, because like even like thinking at a fundamental level of like a cell.
Yeah.
Cells are still kind of trying to organize information, right? Because when they take in like ATP, they're trying to use it for a specific function.
Yeah.
Yeah, anyway.
Yeah, I mean, true. I don't know. I mean, I look at a camera that's like a simple sensor. If I look at a camera and it doesn't have consciousness, it's not preoccupied with organizing the information, it's just information. But humans are things that can perceive, that have a computing unit behind it.
Yeah. But I would argue a camcorder kind of organizes information too.
Oh, true.
Because it takes in some
because
value.
it's programming, right?
Yeah, it takes in some value and organizes it for us in a particular configuration we like, right? If it didn't organize that information, we wouldn't be able to use it.
Oh, that's true, because that puts it in a codec.
Yeah, exactly. It's literally definitely organizing information. It's an extension of our needs.
Yeah.
To organize information.
Well, shit. Back to the drawing board on this one.
Yeah, this is getting abstract.
No, I love it. I love it. These are conversations. These are sort of bar.
I get a little scared of these kind of subjects.
No, I love these bar. What would I call them? Like bar top conversations.
Yeah. But those are better when you're drunk and not on camera. Because if we say something really stupid, then it's harder to back these up.
Well, hopefully to me, I just want to send the listeners on a quest, bro.
Okay, yeah.
I just want
so please don't. If we say something really stupid, don't think we're absolutely dumb because these topics are kind of hard.
We're discussing this stuff live, But anyway, I want to finish the point about this. So microtubules in cells are composed of like basically large proteins, polymers. If you took biology,
no.
But they play a critical role in this understanding of consciousness that Penrose and Hameroff say. The OR theory basically proposes that, microtubules have these structures and networks that could basically function as on-off switches for consciousness and create a sort of. There's also entanglement involved in these, which is also another. What would you say? Kind of to me, it's kind of like a cop out.
Why?
Because it's like you can just invoke. I just invoke the entanglement card to describe something that I can't
Understand?
I
mean, no, it's got to be relevant.
You think
though,
so?
Right? Yeah.
I mean, there's got to be testability. Like you got to be able to test your claims. You know, if you're making a scientific theory of something, you have to make it testable, right?
But entanglement is a viable part of quantum mechanics, right?
So you should be able to use it when it's necessary.
It might suck that maybe it seems like something you can sweep things under. I don't know necessarily what you're talking about in this context, but if you need entanglement, then that's what it is, right? You need entanglement.
Hopefully you can explain something more once you've elucidated yourself, but
well, they argue that it can modulate the information stored and propagated on microtubules. And microtubules, you can find them on neurons. You can see them here. There's a picture. It's just like these long dendrite chains, and you see the neuron cells, and they're connected through these microtubules.
They look like those little things that
went in Neo's stomach in the Matrix.
There's a throwback for you millennial folk.
Yeah. The two types of proteins that make up the microtubules are alpha and beta tubulin, and they pretty much provide the cellular skeleton for the integrity of the neurons. But tubulins can exist in two states at once, actually. Which also gives it the property of like superposition, which make it like a prime candidate for it being quantum mechanical, like the consciousness being quantum mechanical, because like it has more than one available state, than I guess classical mechanisms where it's usually already in one state and it does not change over time.
So it's giving you the choice option now.
Right.
Okay.
And I'm trying to find where they describe it here. It says here, after a chemical signal happens, the neurotransmitter binds to the receptor on the neurons receiving the signal, and calcium ions enter the cell. But these microtubules then add molecular tags through a process called phosphorylation. You add a phosphate group to the chain. And this phosphorylation is, according to the model or the theory, stores the information on the microtubule, so it makes like a copy of, or it stores the signal or information in this phosphorylation group or something. I'm speaking loosely because this is not my main research, and I'm mainly filtering it.
Yeah.
So these changes from the neurotransmitters basically coordinate the tubule states, or the microtubules, to take on a certain state. So it's like a sort of cohesive. They're sort of unique states that configure to each sort of association of like an incident or an event or something. So yeah, and I mean there have been like interesting competing theories about this. Honestly, there was like a proposed theory of, and this is kind of kooky now, but I think it was being thrown around like 20 years ago. It was that the brain is holographic.
I think I heard about that a long time ago. Yeah, around the time of like Deus Ex Machina. Yeah, because that was literally the concept behind his little AI brain. Remember?
Oh, was it? You're giving me news. I don't know.
Yeah. If you remember, like he was like, I cracked the ability to make AI because I made it like holographic or something like that. I don't remember the details, but he used like all of the internet to take in the information. And,
it's technobabble in movies, but it was related to that.
Interesting. No, I didn't see any pop culture surrounded, I guess, by this idea. I just know about it because there was this book that I read, kind of by this weird guy. I think he was a physicist too, but he had like this weird experience that left him with like,
what?
Let's just say he had this impression that he had like the ability to see stuff.
Oh God!
So he was riding on some.
I think
drugs,
something happened. I think something happened to him, and something traumatic happened to him. Like I don't know if he was in an accident or something. But he could perceive things that other people couldn't perceive.
Okay.
And it made him question, the fabric of reality.
I see.
I see.
And so, but in particular, there's this case, I guess, that they make in the book about the brain being holographic in a sense. And for those of you that don't know, the way holographic things work is you encode information. You encode, I guess, a dimension higher of information.
Yeah, I think
right?
so. Right.
So if you're trying to encode information on a two-dimensional plane,
Yeah. But I think there's more to it even than that, because like we can think of like what a hologram is, right? A hologram also encodes like, I think, perspective information. It's like if we took a 2D sheet, depending on the light, we can see around like the corner of an object. And then it also has a property of you can break the thing in half or into portions and it still encodes all the same information.
Yeah. And the reason why physicists thought that, the reason why neuroscientists proposed this theory of the brain being holographic is because there were accidents in which people lost like most parts of their brain and the brain could still function. You would still be able to retain information that was not accessible or could not be explained. Like, why do you still have motor function when this part of your brain that's associated with motor function?
Right. They're saying that the brain has all the information everywhere.
Yeah.
It's just that maybe it's in rudimentary forms or something, or I don't know.
Yeah.
It's weird.
Or maybe harder to tap into. I don't know.
That's the thing. It's weird.
Yeah.
But this is why I think you need physicists. Like, I think you need physicists to come in and be like, hey, what the fuck is going on here? You guys are all like taking in like they're collecting data, but they're like, how do we interpret this?
Yeah.
You know?
I think this is the neuroscientist ballpark though right now.
Okay.
They need it. They have that area right now because I think there just needs to be so much more like modeling and understanding and taking in information. I think there's not enough data.
But do they have the tools?
Maybe not. I don't know if we do, because I think we need a lot of computational power. If we're going in the way of like trying to like map a neuron or something, we might need like quantum computers or something crazy, right?
I mean, if neurons actually are these, it can be in a superposition.
Okay.
I mean, if these microtubules are responsible for this quantum mechanical thing, there's so many. You're basically creating a massive superposition state.
Yeah, I don't think that's how it works.
Think about the orders of I know, but like, I mean, this.
Like, imagine all the shit that bombards your brain. Like,
if you're always collapsing your brain state system, I think you would be screwed.
It's wild. That's why I'm like, I don't know.
It goes.
I mean, I'm more inclined to think that the brain maybe operates on some principle of holography, where maybe the way the neurons fire, you can create projections of. I think this is why the brain visualizes things in your dreams as three-dimensional, and like there's a physical projection that manifests itself in your perception, in your mind, or whatever.
Maybe.
I'm more. That's why I'm saying I'm more inclined to believe this holography principle apply as opposed to like, I don't know. But the origins of it, they can. I mean, I just think you need more physicists to come in, and this is a decent enough attempt. I guess the OR theory, but they propose that it's the most convincing theory, and I'm not necessarily convinced. And these are two. Well, we know Penrose is a physicist.
Yeah.
But if that's all it takes,
Nobel Prize-winning physicist now.
Yeah. But
although he is on the quantum consciousness train, though, so I'm worried.
Yeah. Yeah, I mean, they talk about consciousness events and like when there's a critical threshold of quantum gravity is met.
Okay.
OR occurs, facilitating a conscious event. So just a lot of weird.
Yeah.
This is what I'm saying. Like, you need more physicists coming in and like poo-pooing all this because you're getting one model.
Yeah.
Do you see what I'm saying?
Sure. But I think it's just too early for physicists. I think neuroscientists, the ball's in their court.
I don't know.
It's just too early for us. We can talk and philosophize all day, but I think neuroscientists need to take it.
So neuroscientists, please get more physicists on your team.
Yeah, that's my work.
Yeah.
As long as they have the neuroscientist tools, we need to understand so much more about the brain.
Yeah.
I just don't think we're going to be able to tackle really any good consciousness questions until we really understand the brain.
I think it's an interdisciplinary thing. Like,
I think you're right.
All the great projects that humans have ever like
Yeah.
tried to achieve, like the nuclear bomb.
Mm-hmm.
Well, that was not
Well,
great. But I mean, it was
it's a tour de force, we could say.
I mean, it was it. I mean, it gave us nuclear fission, which can
Yep.
arguably give energy to cheap and cost-effective energy.
Exactly.
to-
With the good comes the bad,
Yeah.
right? Or with the bad comes the good.
Yeah.
But
Yeah.
yeah, I think you're right. I think we just need to. When I say less physicists, I'm just saying that if there's going to be physicists, they need to be listening to the neuroscientists more.
I see.
The neuroscientists are going to be leading the charge, right?
I see.
They need to be making the models, doing the actual like building the infrastructure of how to understand consciousness.
You're saying physicists should take like the role of like let's say an Interstellar, where what's his name,
Yeah,
the guy who made the
McConaughey.
movie.
Nolan. Christopher
Nolan. Yeah,
Nolan.
Christopher Nolan makes the movie, and then the
Yeah.
physicists come in and say that's wrong, but it's this.
Yeah, exactly.
I gotcha,
exactly.
gotcha.
Yeah.
All right.
They have the resources to do it.
Yeah, I'll take that role. I want to be able to say that doesn't sound right.
Right. Well, that's what any physicist dreams of doing. Right?
Yeah.
Just shitting on someone else's work. Anyway.
Anyway, yeah, I was gonna say that's most of the physics community, but I'm not gonna go there. Anyway, folks, yeah, that about wraps it up. If tell which paper did you like the most? I think we're gonna be able to link them down below in the comments, but
Sure. What were the three again? Just so you have it.
so the latest one was with Oumuamua, was with Phi.
Oumuamua.
Yeah, it was with Phizorg.
Oh, Fizzorg.
Fizzorg. Yeah,
This guy, Pfizorg. You
Pfizorg.
got your vaccine. Now you
I'm different now.
now you got Pfizer on the mind.
Yeah, scientists. This was scientists determined the origin of extrasolar object Oumuamua.
Okay.
And
The next one was
the next
the
one was
bird
the birds.
magnets.
Yeah, bird magnets.
Quantum birds.
Quantum birds. You heard it here first. Birds have a mysterious quantum sense. For the first time, scientists saw it in action, and this was published in Nature.
Mm-hmm.
I guess like if you actually want the, it's from Science Alert. I mean, you can look at it in Science Alert.
Science alert.
And then the other one is a neuroscience blog talking about scientists proposing a quantum theory of consciousness, but they were more talking about that review paper that came out, and speaking on this on the developments, I guess, of of consciousness, I guess. But anyway,
Got it.
like, comment, share, subscribe.
Yes. Check out the website, Eigenbros.com. Eigenbros on Twitter, Eigenbros on Instagram, Eigenbros2 on TikTok. And thank you to the patrons once again. If you guys want to sign up and support your boys,
Yes, please
check
do.
us out at patreon.com/Eigenbros.
Yeah, and we'll see you later.
We'll see you guys.
Peace.